Now, electric lines of force. This is another geometrical concept. Electric lines of force. Geometrically, we can draw certain lines around a point charge which actually shows the region in which electric field due to a point charge or system of point charge is in existence. Now question arises, how do we draw electric lines of force? We can draw electric lines of force like this, assuming there is a point charge Q. And if I want to know what is the direction of electric lines of force or electric field due to this charge at point P, we have to keep test charge here. Test charge is always positive in nature. So this existing point charge will, source charge will repel this test charge towards this side. So this is the direction of force or repulsion, and as per this formula, E is equal to F over Q naught, the direction of electric field is same as that of force experienced by test charge. So when we keep test charge here, this will move this side. When I keep here, this will move this side. When I keep it here, likewise you can draw electric lines of force coming out of the positive charge. This will show you the electric field region geometrically. If we have negative charge Q as a source charge, and I keep test charge Q naught here, this will be attracted by negative charge like this. From here it is attracted like this. If it is kept this side like this, likewise you can draw electric lines of force for the negative source charge like this. So just have a look on these two figures. When we have source charge as a positive, electric lines of force are moving outward from the source charge. While when we have source charge as negative, electric lines of forces move towards the negative charge. The number of electric lines of force increasing in a certain region means electric field strength is becoming stronger and stronger. So number of electric lines of force around any charge depends on the magnitude of a point charge. We can also plot electric lines of force and show electric field region geometrically for a system of point charges. Say for example, if we have 2 point charges which are kept nearby to each other like this, one positive charge, another positive charge is kept, and if I keep test charge here Q naught, this is the point where force exerted by this charge Q and this charge Q on test charge is are equal in opposite directions. Therefore net force acting on this test charge at this point is 0, and this point will be exactly a central point of the line joining 2 point charges. So this is called neutral point or null point. This point P is called null point. Since there is no electric field at this point, so geometrically no electric lines of force would pass through this point. So when we plot electric lines of force for 2 positive charge system equal in magnitude, say Q1 is equal to Q2, then it looks like this. You can draw a line passing through the center, which is a null point. Electric lines of forces are moving outwardly from a positive charge in this region, in this region, and in this region, and then here it tilts like this. Here also it tilts like this. No electric lines of force will touch this null point line passing through the null point, because there is net electric field on this line is 0. Similar diagram you will obtain for 2 point charge system when both are equal in magnitude and negative in nature. Minus Q charge and minus Q charge. Again you will obtain null point here somewhere. So the electric lines of force, only the direction will change. Here vector will be inward, and for positive charges it was going outward. Likewise here you can plot in electric lines of force. But if there are two positive charges or two negative charges, but both are not equal in magnitude, suppose Q1 is greater than Q2. In this case, Q is larger in magnitude than Q2. Both charges are placed along the same line. The null point will not lie exactly at the center, but rather it will shift towards a smaller magnitude charge. So null point will be somewhere here. Then electric lines of force will look like this. We can have another system where one charge is positive, another is negative, and total charge on the system is 0. We can call this system as Q1 plus Q2 equals to 0. This is a mathematical equation for this electrical system. When we plot electric lines of force, we keep test charge, it will be repelled by the positive charge, attracted by negative charge, so it will straight move towards negative charge. If I keep it here, the electric lines of force will have this shape, moving from positive, terminating at negative, like this. This will go somewhere far, and likewise you can show these are the lines which is coming far off and finally terminating at negative charge. This particular electrical system is termed as electric dipole.